Hello and welcome. I'm your host, Adam Hawkins. In each episode, I present a small batch of the theory and practices behind building a high-velocity software organization. Topics include DevOps, Lean, software architecture, continuous delivery, and conversations with industry leaders. Now, let's begin today's episode. Today, I'm speaking with Derek Comartin. Derek is a four-time Microsoft Most Valuable Professional. He has 2 decades of software development experience focusing on software architecture, CQRS, event sourcing, messaging, and .NET development. I found Derek on Twitter through a link to a blog post on the loosely coupled monolith that piqued my attention. That led me to his YouTube video titled Context is King, Finding Service Boundaries. That's when I knew I was hooked. And I could tell that Derek and I are cut from the same cloth. Both of us have similar ideas. This goes back to a talk I gave in 2014 titled Application Architecture, Boundaries, Object Rules, and Patterns. The same ideas in the talk apply to services. So I invited Derek on the show to discuss his rules for designing distributed systems. Because, dear listener, as you know, there's a strong correlation between high-velocity software delivery and service autonomy. This also speaks to Conway's Law and team topologies, but hey, we've already done an episode on that. Basically, if you want to go fast, then you got to decompose systems, and that requires defining context and setting boundaries. So with that, I give you my conversation with Derek Comartin. Derek, welcome to the show.
Thanks for having me.
So I wanted to have you on the show to discuss some of your work online related to the breaking up of monoliths, the construction of microservices, sort of the relationship between software architecture and the services, and sort of the idea of bounded context around services and how that fits into the overall architecture of systems. So for the listener, why don't you give a little bit of background on kind of the systems that you worked with and how you came to your philosophy on software design?
Yeah, so what you're alluding to was kind of a series of blog posts and videos that I had recently about creating a loosely coupled monolith. This is kind of like what I called it. Mm-hmm. I didn't want to use the term modular, and the reason being is because most of the, I'm not saying there's not content out there that does this, but a lot of the content I was seeing relate to a monolith ultimately having the term like a big ball of mud. Like there's just this equation of people thinking that monolith, there's no way you can create a modular monolith, and never mind modular, because I get the feeling when people think modular, they think of, okay, just components that are, how they're even loosely coupled, nobody really knows. There's some invisible boundary. Mm-hmm. So what I wanted to describe with a loosely coupled monolith was that you can take a lot of the principles that are being used, that have always been used in SOA, mm-hmm. and that are semi-used in microservices, depending on what version of microservices that you're talking about. Mm. And basically just define clear boundaries about what your system does, and then communicate asynchronously through those boundaries. So a monolith doesn't necessarily need to be that everything needs to be done in process. It's just taking this idea that you can have a single code base with well-defined boundaries even within that code base. And when you want to communicate between those boundaries, do it asynchronously.
Yeah, for sure. And I like the concept of sort of a loosely coupled monolith in the sense that I think that there's maybe kind of an assumption, or at least this has been my own experience, that, a monolith is a monolith in the sense that it's going to be like one process that's deployed that's doing everything. But even inside like one boundary of a whole service, you can have one process that's doing this or one process that's doing that. Like they can maybe all be sharing the same code, but there's nothing that says like all of these things have to be highly coupled into one cohesive unit of code and all run and deployed in that way. Is that kind of what you're getting at?
Exactly. Right on the money. So that's the thing. And I've mentioned this a few different times at conferences and had discussions with people, is I'm still trying to figure out where this came from, is that the idea that you have a single repo that represents a single project that gets deployed as a single unit, where all these things just became that they have to be a one-to-one-to-one. Mm-hmm. and they don't at all. Like, so in my examples that I was using is I actually have two top level executables processes. One being just them both being entry points. So one being, say, if you're creating a web app, if it's just an HTTP API, that's one kind of interface to the application. And then the other being where the loosely coupled part comes in with messaging is something that's just strictly picking up message from a message broker and then dispatching them to whatever relevant part of the system is good, basically needs to handle those. So even when you start thinking about microservices, and again, that's why I said, like, depends what your definition is because I think there's this, it's like, I think if you were to ask around, like, what are microservices? Like, what are the kind of the tenets of microservices? Well, there's tenets of SOA. There's defined rules, guidelines that you need to be following if you like, that are kind of established. And those were by, I believe, Don Box in like early mid 2000s. But there really isn't that for microservices. And it's kind of good and bad that there isn't a strict definition. But unfortunately, I think with a lot of things in our industry, there's concepts and terms that just have wildly different meanings to people.
Like end-to-end tests or integration tests.
Yeah, anything to do with testing, like, good luck trying to get a clear definition of what that means to people. REST is just become synonymous with HTTP.
Yeah. I
mean, you might as well not even say, I don't even bother saying it anymore because it doesn't mean what, I don't think it means what you think it means type thing, that meme.
Yeah.
There's just so many things that are that way. And I feel like microservices are one of them where I just go back to more of the tenets of SOA, and the biggest one being autonomy. And that's kind of goes with the loosely coupled monolith, is still having autonomy even within boundaries within that monolith.
Yeah. So before we get into boundaries and context, I think it's good if we set some terms, define some of the things that we're talking about. So I like how you brought up SOA, because one thing that I've kind of been going back and forth in my head for a long time, really, is what is the actual difference between microservices and service-oriented architecture, in the sense of, like, is it actually technically different in terms of like how it's done, or is it just the fact that, like, say, is it SOA if you have 10, or is it microservices if you have 100? Like, where's the boundary? What's like sort of the spectrum of these things? Because at least sort of how I would approach it, the architecture principles I would use to build a service-oriented architecture are the same that I would do in microservices. Just that if you have 1,000, maybe you have to change the way that you work, like, as an engineering team to support them. But like on the technical level, the architecture level, you would still, enforce a boundary between services. You still have an API, you still have autonomy, you still have like data ownership, all these things that I don't think they would be different if I had 2 or 200, So I'm going to guess, based off of the work I've seen, that we share the kind of the same definition of a service, which is, in my mind, it's some independently developed unit of software that's deployed and communicates with others over an API. Like, kind of broad, but it's sort of, I think it fits for me. How do you see services?
Pretty much the same way. I mean, I can't really give you a definition of what the difference is between a regular service and a microservice. Like, what does that size have? I mean, if you go back to the whole, 2 pizza team thing, like, I don't even know what that means. Like, I mean, it's relative, you get what it means, but it's really about what can an individual team can take responsibility on to develop and manage. And if that's their, if they own it and they have to deal with it, it's whatever they can, like, whatever their capacity is.
Right.
So if you have really small teams or a little bit larger teams, I just think the term is so weird. I think maybe what happened and why it happened is because in the SOA world, things got a little sideways with enterprise service buses and that kind of dictating where traffic flowed, rather than now it's more of a, what you call dumb pipes, smart endpoints. So like you have messages, they understand whether they need to deal with them or not. There's no There's no orchestration of routing. But at the same time, again, this is just my assumption on the feeling of when I read blog posts and Twitter, and that's not to say I'm in my own bubble clearly on Twitter, but with microservices, and even back in the kind of SOA 2.0 version, is that they're got this push to be everything to be synchronous. So I'll use, like, I am not speaking for inside knowledge or even how this works, but I'll use the example of Uber had their blog post about their, I don't know if you read that article about Doma.
And even the one like few years before that, where they're like, oh, we have 2,000 or 3,000, whatever, however many. And
they said like a little over 2,000 microservices. And the beginning of the article kind of makes a lot of sense to me, because it said like, okay, we started off as a monolith, and then it just, I don't know how quickly it exploded, but it exploded to 2,000 services. But it makes sense, because if you are in an organization that is growing, I'm assuming here, that rapidly, and Conway's Law, this is going to happen. You're going to end up with multiple teams working on these things. And if you're trying to rip apart a monolith that is tightly coupled, I'm making assumptions here. I'm just not using really Uber. You can think of any system that's getting large and is really growing that's tightly coupled. If you have a lot of inner process communication, how are you going to rip that out and make separate services? Well, you're going to call from service A to service B that you pulled service B out. You're going to now have to call it synchronously over HTTP or something over the network.
Yeah.
So then you end up with a distributed monolith, ultimately.
Even worse.
And I'm not saying theirs is that, but I will say if it isn't, then they did a really poor job explaining that how they use messaging, because they never really mentioned in that post anything than RPC. There was one little kind of graphic that showed a mention of kind of events, but I don't know how that fit into the mix. But I'm always curious to know what the outside world right now, that people are developing microservices, how much they are using RPC and how much they are using messaging.
Yeah. So deciding on how you communicate between these different services is actually really important in terms of your overall architecture. Is it going to be synchronous? Is it going to be async or whatever? The last time I went through this exercise was breaking up Monolith, and was really lucky in the sense that I've been working with the company for a while, and there was pretty well established what I call like fault lines inside the monolith, where you could split things out, where there was already some kind of quasi APIs in the sense that there was a class definitions or method calls, and you could sort of imagine that, okay, this could be just, cut out here, moved over here, and, you could do that. And when we did it, this was back in 2014, 2015, I can't remember. But we had decided to use a thrift for RPC all, between all the services. So that worked out pretty well. But, the definite other areas, of course, async. And then the question is, are you going to have a centralized like message broker, or are you going to have like independent streams? How do you decide sort of the level of independent, like decentralized versus centralized? So like if you think about it, where do you kind of fall on that spectrum?
So how did it work out with everything being RPC and when it got split up?
It was fine. Like we had also the ability to like background certain things when we had, say, like a request come into some web server, the user does something, it's going to have to send an email. That just queued up a background job to execute asynchronously, but when the job executed, it would make a synchronous call to email service to, send some email. And if it failed, it would retry. But the issue with the synchronous thing is not necessarily from, it's like in my experience there, like the operability, but the expandability. It's like when other parts of a system have to hook into other parts of the system, it's nice not to have to actually make multiple RPC calls, but say, hey, I'm publishing a message to this place. Anybody who needs it can listen to it and then do something, right?
Yeah, I guess it depends on how much explosion happens of these services. Like, I think Uber is probably a little bit extreme in their example of having two monoliths or whatever it was that goes into 2,000. But even in their post, they mentioned like, okay, well, troubleshooting, you had to basically look at, I don't know, like a dozen different services.
Yeah.
Somewhere around there. I can't remember exactly the number they said. It was at least a dozen that you were using to trace through requests or whatever the issue is. And that sounds horrific to me. That does not sound like a good time.
Oh yeah. When we did this exercise, we went from like a one monolith to something like 10 different services. But the topology was designed specifically such that there was no cycles in the sort of the traffic through this, or at least as minimum as possible. Certainly not in the synchronous paths, because as you say, if you're going through, more than two, basically something that's just, it's like, that's too much, right? You can't go more than one dependency deep to actually care to debug it. You get into the, the questions of, okay, what in a big enough organization is like, whose team is this? Like, who are the people that maybe even operate this? I have no idea, right? And then that's when you get into this like distributed ball of mud, which is even worse than a centralized ball of mud, in my opinion.
Yeah, I'd agree.
So let's bring the conversation back here to sort of defining the service and setting the context, right? So you have a series of blog posts on context is king, also YouTube video, and it kind of fits into the idea of a loosely coupled monolith is that, if you have a loosely coupled monolith, you could run one process as this or one process as that, whatever, and then even if you wanted to actually separate those things out specific, like entirely, you could, right? But that all comes down to following, strong software architecture principles in the beginning. So what's kind of the list that you have enumerated so far?
So you alluded to it. Boundaries are like the most important thing to get right, but I find them the easiest to get wrong. So it's kind of unfortunate. And there's really there's a lot of strategies I have for doing that, but it's not really there's no prescription on how to do it. It's really having to understand the domain that you're in, the problem that you're trying to solve, collaborating a ton with the business so that you can really get a grasp on like what the surroundings look like. My analogy for this is, especially when you don't know a domain that you're working in and you're trying to figure out where these boundaries are. To me, my analogy is you're going into a dark room that's pitch black and you have a flashlight. You've never been in that room before, but you're just pointing that thing around, trying to kind of get an idea of where the walls are, how tall the ceiling is. And as you kind of work around the room more and more, you kind of get a bigger picture. Like you get a better mental model of what that looks like. And at first, if you try to find those boundaries, and you just shine that light just in one side, you're not going to get it right. So it takes a little bit up front to kind of feel where those are, especially. And there's ways of doing this. Some of the ways I've mentioned before, and this goes back to domain-driven design, it's the language people use. It's kind of an easy giveaway sometimes, how the term things. I've noticed in our world, there's a tendency to create services around entities. So like entity services, meaning I have a product and I just have this one service that does everything for a product. And that's not really the case. So my example of this when I worked in distribution was I used to say a product isn't a product isn't a product. What I mean by that is depending on who you talk to in that organization, in that distribution company I worked with, they view a product differently. So if you're talking to somebody in sales about a product, they care about the sale price, they care about margins, they care about their customers, different pricing levels, maybe how all that works. If you go to talk to somebody in purchasing and you say the word price, they're not talking about a sale price. They don't even care about the sale price relatively. They're talking about, if you say price, they're talking about cost. They're talking about the vendor price, like the cost to you. And then if you're talking to somebody out on the warehouse floor, they care about none of that. They care about locations, bins, aisles, a whole whack load of different things. And then accounting, that's a whole, is a combination of stuff, right? But a product isn't a product isn't a product. So this idea that you have one service that just is the owner of all the data related to a product will end up making you have to be coupled to that thing. versus is if every service that, say you have like a shipping service and a purchasing service and a sales service, they would each have a quote unquote version of a product entity with owning the particular piece of data that they should own, right? So like language is a kind of a giveaway when you're talking to people about this is, okay, somebody said this, you said this. Do you even care what that person is referring to? Like when they're talking about the sale price or et cetera. So a lot of it's just in communication to kind of figure out where those boundaries are. So that's probably, but again, it's not prescriptive. You got to do a lot of legwork to get your mind into the domain.
Oh yeah. And this is why I feel especially bad for teams that start with microservices, because how do they know where those boundaries are? Especially, I really like your analogy of you're in a dark room and you're exploring with a flashlight, because when you're in a new context, a new domain, you don't fully understand it, and you only come to understand it over sufficiently long enough timeline, given enough experience, enough trials, like successes and failures as you find what does and doesn't work. If you're going to just start from T0 and say, oh, I'm going to have this over here and this over here, they're going to talk like this is how everything's going to flow, you're going to eventually going to have to pay back that debt in some way, because odds are things aren't going to fit the initial model of the world that you had when you created it. So like when you start from zero and you build up a system and it gets larger, then of course, if, as you say, Conway's law will happen. You're either going to try to find ways to split it, or you're going to create new stuff outside of that, so people can actually do the work that they need to do. But yeah, your product isn't a product gives away like the other part of this. I think I see where people making mistakes is that they assume that service boundaries should be around like data entities themselves and not necessarily the functionality they provide in the whole system, right? Because if you're making a service that's just like, hey, I can store products, I can get products, it's basically just REST in a different form. But what does that do besides exposing a database over a different interface? How is that useful?
So yeah, that's the other piece that I kind of try to mention, is that it's behavior and data go hand in hand. So while data is useful to look at, like if you're looking at, say, for example, say you have this product and you're like, okay, we have price, costs, all this stuff. And you're like, okay, clearly this isn't going to be just one thing. It's going to be broken up into multiple contexts. It really is then starting to look at the behavior around the data, because they have to go hand in hand. If you just have data, well, guess what you have? A database, right? Like that's all it is. And if you have a service that doesn't own any data, to me, that's not a definition of a service. I don't know what we call that, but it's not a service.
Oh yeah? Interesting.
So data, behavior, hand in hand. Now, the piece of like, okay, well, what behavior belongs where, and you're alluding to it, is get rid of this notion of that it's all about entities, like we were alluding to. It's about what capabilities do your service provide, right? And then once you start defining what those capabilities are and grouping them together, but okay, these are feature sets that we need, what pieces of data are going to either change state, what pieces of data do we need to own, and you start figuring that out. Then I think that's where you start to develop a boundary. And like I said, I think you're going to probably end up getting some stuff wrong and putting some behavior in places that where it ultimately shouldn't be.
Mm-hmm.
But that's just with building more aha moments along the way that you realize, oh, that was a bad idea, right? Like it's just going to happen as you gain more insights into the domain, and as you communicate more and really understand the problems, that you start to kind of redefine things. So that's why I said it's really hard. It's really important to get right, but it's really hard to get right from the beginning.
Yeah, there's really like important rules of thumb, like first principles that you have to adopt to actually set the boundaries in the first place. It's like I come at it from the perspective of, if you're trying to create a new service, what that to me kind of communicates is you have the concept of a bounded context. You have some hard boundary you can draw that inside this, that has data autonomy, it's full control. It could be a data store, any number of data stores, whatever. You have defined some sort of behaviors or functionalities that you can offer to some consumers of your service. You have an API to do that, and you can develop and deploy this thing independently. Now, if if you don't have that model in your mind, you're likely to do things that are just horrible mistakes, like, oh, I will just read some data from some other things database, or I will communicate through like, some number of like back doors or like non-advertised APIs. You'll do all these things that sort of just violate the principles of the boundary. But if you don't understand what needs to be in the boundary in the first place, then you can go wrong in so many different ways that don't actually give you that isolation, but just end up smearing out different parts of the system across just different code bases.
Yeah, and then I think too is that, and even if you kind of get into this entity as service idea, is that you end up just with a ton of RPC, and depending on, I guess, the system, there's a lot of implications right that with. So if you have, for example, some user makes a request, it's coming to your service, and then you need to make, say, subsequent 3 calls to 3 other services. If any one of them has high latency, or if any one of them's unavailable, like you're dealing with all that. And how do you deal with it? Right? Like it's just another thing that you're dealing with because you're making kind of that distributed monolith. I feel like that is the case that a lot of monoliths that get broken up go into, is making a lot of breaking things apart and making things RPC. And that was kind of the point of my post, is really saying, okay, if you don't do that, if you start this way and you do want to carve things off, you're independent to begin with. So it's really just about the strategy I was showing was, okay, you can be asynchronous, but you can still roll these things up into 2 top level executables. And technically they could have only been 1 process that's really running. But it just so happens that they all get deployed together. But there's nothing stopping you, like you said earlier, from saying, okay, we're going to take this one off and deploy it independently because maybe it gets more traffic or has different load or et cetera for whatever reason. And because maybe you start revving that one differently and you don't want to deploy it with everything else. Maybe, there's more, maybe you're developing more of a risk to deploy those monoliths. So you want to have a different strategy so you can let some pieces that aren't changing much, leave them be, and then deploy, the pieces that are a little bit more.
Yeah, that's one of the other factors I think is really important in setting up sort of the boundaries, because the boundaries there's technical boundaries, but then there's also organizational boundaries, right? And Conway's law is a law in the sense that it's going to be hard for you to create a new service if it's spanning across like 3 or 4, n different teams. I mean, we really want to localize these services to like one team and avoid spreading them across multiple teams wherever possible. So like you have the boundary from the technical sense of like APIs in this whole context, but then you have the boundaries from the organizational sense as well. And like one thing you mentioned, the changeability, is that there's some, there's some pieces of code that might get changed every day, even multiple times a day, and some code that may not even change more than once every 3 years. So the level of maybe, for want of a better term, how much you care about the thing that changes every 3 years compared to the thing that changes every day, there's a different level of commitment you have to keeping those code bases, well maintained. So you should also consider changeability and maintenance concerns when you're setting up these contexts and boundaries in your system.
Yeah, and I mean that's a thing too. It's context does matter. So like you said, as the way things are today in your software, in your organization, or whatever you're delivering, is not obviously going to be the same as what it was. I'm thinking of the software I'm working in now. It was greenfield 5 years ago, so it's clearly very different from what it was. And how it's got deployed has changed drastically over time too. And when you just said there's parts of the system that change very frequently, which is very true for us. And there's parts of the system that don't change, if not, I couldn't even tell you the last time parts of it have changed, because they're not really the core piece of the puzzle for us. They're just kind of the fringe, a lot of it related to kind of configuration setup that it's there. It's what it is. It doesn't need to change. Yeah.
So I want to get your opinion on the asynchronous part of this. So and this kind of speaks to one of the questions or points I brought up earlier with what's the difference between service-oriented architecture and microservices? And when you get into microservices, it's not necessarily the software architecture that changes, it's the infrastructure concerns that change. Because managing one versus managing 1,000 requires, it sort of just brings in the assumption that to me, I don't know how you feel about this, but when I hear microservices, I don't really think software architecture. I think infrastructure architecture, which implies you're going to do something like Kubernetes or containers or whatever, there's just going to be something like that, as opposed to, hey, I have one thing, maybe I'm deploying it to a VM, and it's a whole different approach there. But as far as async messages go, where do you stand on centralized message brokers or buses for all the different services, or different messaging streams for the different services? If you're say using something like RabbitMQ, you can have a centralized broker and set up all the rules there, or you can do in AWS, you can have Kinesis streams, or for each per service or something like that. How do you feel about this area of software architecture as it relates to SOA or microservices?
Yeah, so that's the comment I hear the most often is okay, well, yeah, you're going to messaging, so now you're just completely reliant on a message broker. It's well, yeah, That's
the point.
They have to get distributed somehow. But the idea still being right is that you don't care who the consumers are. You're just publishing messages, and whoever the consumers are, so be it. Now, whether you need to concern yourself with, okay, well, where are these message brokers that is there a central broker? I really honestly don't have a hard opinion on it, because I think it really depends. Generally, I've been more of especially now with everything being so redundant in the cloud, it's that I'm not so concerned with having a single, say whatever you're using, if it's RabbitMQ, or if it's, obviously this is not a queue, Kafka, but it's a log, but still, I guess if you're in the cloud, I'm not so concerned with having a single point. I guess it all depends on the number of services that you have, right? If you have this little cluster over here, that's 5 different services or whatever, say it's 20, talking about microservices here. And those do a lot of interactions, then yeah, maybe they know, where that message broker is, but you don't even necessarily, that can all be abstracted from you too. So I don't really have I think it depends on probably the volume and the size. There was a post recently from, I just seen it this weekend, a food delivery service, not Uber Eats,
Bite Squad or something. I don't know.
I can't remember.
Was it on Hacker News?
No, I don't know where I see it. Skip the Dishes, maybe. And they mentioned that they moved from Rabbit to Kafka. And the reasons that they moved from Rabbit were, I believe, just the volume. It couldn't handle the volume they were producing. But they have a whole blog post on it. And I think it makes sense. It's they went through great lengths of trying to basically re-implement what they had with Rabbit using Kafka. And seemingly from their post, it's worked well for them. But they had a lot of availability issues. So I think it's one of these things that you grow with. I don't think there's any set rule on you. Okay, you have many or you have one.
I think it depends on the ownership model of this particular thing. Because if you're going to have, say, X number of services, and you're going to share some common communication method between them, somebody in the engineering team is going to have to own it. And this kind of becomes one of these horizontal supporting layers that some platform team, ops team, whatever you want to call them, DevOps team, blah, 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 they're going to end up being the sort of arbiter of that bit of infrastructure. And then how does that relate to the other teams that are publishing messaging, consuming messages, and then if they want to add a new service, what's the process? Sort of gets into one of the other factors is kind of the governance model of how the engineering team is going to approach all of these different services, which I don't know how it's been in your experience, but in my experience, teams don't tend to think of that kind of governance. What are we going to do if we have a new service or this or that? It's just, let's just start doing it and see what happens. But you got to do a little bit of planning up front. Have you seen something like that?
Well, I think I think there's a lot of things that we don't think of as developers. I think that's probably, I think it's gotten better though, in that sense because I remember a long time ago, it's like developers didn't touch infrastructure, right? Where that's come a heck of a long way.
Yeah.
So yeah, but I mean, I think there's a piece of that is not even just necessarily where that infrastructure lives, who owns it, but it's even to the level of how you are using it. So, for example, like what those streams of data look like, and what those like in what those where you're publishing stuff. So, for example, if you've ever done anything like this, is kind of maybe a good or bad analogy, depends how it goes here.
Let's find out.
If you're talking about something like event sourcing, and that's another term, unfortunately, that I think has lost a little bit of its definition, maybe, or I think it's getting a little bit depending on who you ask, they have a little bit of a different definition to it. Mine, however, is that of an event stream. So when people say event streams, I immediately think of event sourcing. I think of the series of events for a particular instance of some entity. So if I'm talking about the prototypical example here is of a bank account, it's bank account 1234. That's my bank account number. That's my stream of all my transactions. There's not one global stream for all transactions ever. It's not partitioned that way. There's a stream for that particular, bank account or whatever it is. If you have an order, it's that order ABC 1234, whatever that number is. So how stuff gets partitioned, because even that, when you're talking about what I'm alluding to with event sourcing, you have to decide how you're going to partition that. And you're going to have to decide what that model looks like. So I think the same thing applies to however you're publishing messages and where you want to publish messages to. So if we're talking about Kafka, if you're talking about like a log, if you're talking about using something like Event Store DB as essentially a queue, because they can do kind of competing consumer stuff too, or whether you're using Rabbit or SQS and SNS, yes, somebody's got to manage all of it, but even beyond that, like even before that, it's how is all this getting partitioned, which is a whole nother concern, right? So, and that ultimately is kind of that between teams, this middle ground of where does this all, like whose responsibility is this?
Yeah, and also like what's the sort of the contract between the publisher and the consumer? I read Martin Kleppmann's Designing Data-Intensive Applications, and that book actually changed the way I thought about software, because it introduced, I was not familiar with Kafka at the time, but it introduced the idea of the global log. You could replay stuff and write everything there. But the other part of it was Avro, with the idea of these like backwards and forward compatible schemas that you could publish a message onto this log at one point in time, and then X number of years or whatever versions down the line still get something that you could consume. And so if you're doing something like RPC or REST, HTTP, JSON, whatever, you're going to define some request and response format. Whereas like if you do messaging, you still have to consider that. So yeah, for sure. Like if you're talking about Rabbit, right? Like, okay, you consume the message, see you later, it's gone. If you're talking about something like Kafka, that you have whatever retention, it's not forever, that I'm aware of anyways. Yeah.
But if you're using something like Event Store DB and you're creating streams that are consumable, well, those events don't go away. They're like, if you're creating some projection and you're going back to the beginning of time, well, that event, what you created 4 years ago, whatever that schema is, that's still what it is. So you need to handle that schema, especially if you're dealing with really old events. Yeah,
that's actually one of my favorite kind of aspects of that particular architecture, is the idea that you could recreate state at a particular point in time by just replaying all these streams. So if you're dealing with like, say, transactional systems or whatever, you just need to have a snapshot of how many databases there are at that point in time and hope that they're all in sync.
It's really cool. Yeah,
it's really cool. And I think one of the levers that you can pull on in microservice architecture, like if you can adopt like really full asynchronous stuff, you have just a really scalable architecture from like the operable side, but also like from the sort of the Conway's law side of being able to change it as teams grow or go away and new requirements come and all that. So I think that your focus on asynchronous messaging is really important. And how did you come to that as a really important point in the architecture?
So this actually just came up the other day, and I thought about it for a little bit. Was because a lot of this stuff way back when I used to do the same type of thing, but in process. And obviously, when you're doing stuff in process, if something fails, well, then you have your own code, not library code or whatever you're using that's sitting on top of whatever message broker. You have to implement all your own retry logic, timeouts, circuit breakers, like all this stuff you have to implement yourself if you're generally trying to write this all yourself, like to do it all in process.
Right.
To say like, okay, I have this event and I'm going to find implement the code base. I mean, I'm going to, however you determine what the handlers are for it in the system and you kind of invoke them. But if each, if you have 3 different event handlers and one of them fails, well, does the entire initial request that started that whole thing fail? So that's actually, I think, how it started for me is, okay, well, I want to have everything be done in isolation.
Mm-hmm.
But the cool thing about what I don't think is leveraged enough is thinking about the same paradigm that you can use for messaging, for whether it be an event or a command that you're getting from a queue, is that you can take that exact same paradigm and think of it as in process. Like it almost becomes indistinguishable. So what I mean by that is if you have a request come in, say you have an HTTP API, and you convert that HTTP request to what I will call just an application request, if you will. So you have some object or message that represents kind of the data, the request of the data. And then if that gets dispatched, so you have some dispatcher, and there's a bunch, I'm assuming this exists in probably every language and platform, but you have a dispatcher that will take that message and then send it to basically the right handler for it. And this is all done in process. But you can take that same notion and then apply that to, okay, well, instead of sending this in process, I'm going to deliver this to a queue. And then that's what's going to process that message is going to be the exact same handler that you were previously doing it in process. So you end up just, when you start writing your application, everything becomes of handling messages, pretty much, like right from the get-go. So that's how I think, started going down this road of asynchrony between things is just the being able to deploy things in execute things in single units, like in isolated, and let them dictate the things that you need, like retries and timeouts, etc.
Yeah. And that speaks to leveraging the capabilities of different technologies, like retries and these things. Oh yeah, you can put them in a queue and you get all of these like other things for free. And then you mentioned single units of functionality, which then feeds back into a better software architecture, because now you have the ability to develop and test them independently. You can really say with high certainty that, hey, message X comes in, A, B, and C happen. All these, you can just say, boom, I know exactly what's going to happen. You can then chain all those things together and whatever. It becomes easier to isolate, which then feeds into the fact that you can separate them out. You can move these systems in different places, and it creates this really nice virtuous feedback loop that if you start to think about it, it feeds into all these other beneficial areas.
Yeah, I think you touched on a big one there, is the testing of it. And I think where it also will lead people immediately into is thinking of, it kind of automatically brings you into this kind of CQRS. CQRS is kind of a gateway drug, is what I like to call it.
Yeah, I can see that.
It's super, super simple. People conflate it with a pile of other stuff like like what we've been talking about, but it really is just as simple as commands and queries, separate things entirely. But I found that once you start getting into it, and especially if you're applying it with messaging, you get into this mode of vertical slices. So you stop thinking about layers and you start thinking about vertically. So I always like to say, if you think of like your service or your application, whatever case may be, and you have layers. Let's say you have the typical data access layer, you have a business logic layer or domain layer, you have some UI, whatever the heck you want to call these layers.
Mm-hmm.
But generally, these things are thought of as kind of like application-wide type things. When you start getting into vertical slices, you stop thinking about that. And you start thinking about the single unit of what the piece of functionality is that you want to provide.
Mm-hmm.
And then within that unit, you think about layers.
Yeah.
So what it makes things so much easier to test, for one. But two is, if you start organizing code this way, you 100% stop organizing code by layer. And you start putting things that are related together. So you start putting features together. You start putting things very close together. So depending what language you're in, obviously this works differently, but whether they're in a single folder, a single file. So when you're talking about, I need to go edit the system, I got to add some feature to or modify some existing feature. Say it's to something in shipping, related to shipping. You go to that folder that's 100% related to that feature, and you know exactly what you're doing. You're not jumping around projects. You're not jumping around different files. You're just going specifically to the heart of what you're actually dealing with.
Yeah, and this vertical slice sort of starts to bring you into the like domain-driven design type of thinking, because now you have this sort of isolated area where things are all related to the same thing. You probably speak the same internal language inside there, and that when you go from vertical slice A to vertical slice B, they're different on purpose because they are for different things, and they can, be their own shape or adopt different, even like internals in the software architecture for what makes sense inside that particular box. Like, I totally agree with your point that like application layers, that's like for internal teams, like you might have somebody inside one of these teams working on these vertical slices who's better at infrastructure or better at CSS. I mean, please don't ever make me write CSS, but you have people who like to do that and they're good at that. So great. Like, you need those people on your team. Like, empower them to work at that level inside this whole vertical slice or context of this particular function or feature,
Yeah, like a vertical slice can be as big or slim as you want it to be. It could be a collection of features. It could be a single like command. And you just touched on it, which is, once you start doing that as well, is that you start deciding dependencies. And you kind of mentioned like the shape or the internals within that unit, within that vertical slice. So for example, there's been many benefits of doing this. One of the biggest reasons that this has paid off is being able to do that. Is technology moves so quickly, your skills change, your knowledge changes. So all of a sudden, if you want to say, okay, we've implemented some new library or something that's making our life a lot easier, or we want to stop using one and start using something else, or just how we're doing something, you don't need to change and rip out the entire service or application to do that, right? You're not ripping it. I got to rip out the entire data access layer. No. You're doing that. You can start doing that on a per vertical slice feature basis, right? Because those things they're siloed. They're pretty much independent, generally for the most part. And yeah, you're going to have some shared things between them. You'll have some shared concerns, like maybe some data models or et cetera. But for the most part, they're little slices of cake, so that in those little slices, you can decide what you want to do with them.
Yeah, I mean, and that's really what it comes down to when we're talking about the idea of like context and boundaries, is that they're there exactly for that reason. If it's inside one code base or across independent services, or even, across groups of services, the only thing that I think really matters in software architecture is boundaries. Because if you don't have that, then you don't have anything, and if you don't have the boundaries, you don't have interfaces, you don't have APIs. And if you don't have APIs, then what do you?
Yeah.
Frankly, what are you doing?
Yeah. If you don't have boundaries, I like the way you say, if you don't have boundaries, I don't know what. Yeah, you don't have anything at that point.
Right, because if you come from a system or an environment that has these like well-defined interfaces, these boundaries, and then you look at this like ball of mud or like just things were smeared, you just look at it as like, I don't know. No, what is this? This is how do you make sense of it, right? Because it's here and there and all this and all that is just. it doesn't work. That's why I really liked your video, Context is King, and just the idea of like really beating on the fact that boundaries are really, really important, and that it's really worth it to, like in the beginning, explore the problem domain with the flashlight, learn the room, figure out where the stuff is, and put those things in place. Yeah. So we're out of time now.
Figured we were close there.
Yeah, I don't think there's anything else I'd like to ask you. Is there anything else that you'd want to add to the conversation before we sign off?
No, I'm good.
No. Okay. Well, Derek, I'm sure we could talk more about this. I can tell that you and I are kind of kindred spirits in this discussion. So it was a pleasure talking to you. Is there anything you'd like to leave the audience with before we go?
Sure. If you want to check out any more of this, just my blog, codeopinion.com, has pretty much everything we've been talking about. So that's pretty much my focus.
And you have a podcast too, right?
Yeah. So James Hickey and I, another fellow Canadian, we have a podcast called The Loosely Coupled Show. So you can find that on wherever you get your podcasts from, basically. So it's The Loosely Coupled Show. What
do you talk about on the show?
Everything that we're talking about right now, basically. And we have guests. We should definitely get you on there. But yeah, it's a little bit all over the map, but a lot of it obviously is about software architecture.
Yeah. All right. Well, Derek, thank you so much for coming on the show. It was fun and hope to talk to you again.
Appreciate it. Thanks.
That wraps up this batch. Visit smallbatches.fm for the show notes. Also find Small Batches FM on Twitter and leave your comments in the thread for this episode. More importantly, subscribe to this podcast for more episodes just like this one. If you enjoyed this episode, then tweet it or post it to your team's Slack or rate this show on iTunes. It all supports the show and helps me produce more Small Batches. Well, I hope to have you back again for the next episode. So until then, happy shipping. Want to learn more about DevOps without wasting your time? Then sign up for my free email course at freedevopscourse.com. My course combines the best from the DevOps Handbook, Accelerate, and years of software delivery experience. You'll learn the 3 ways of DevOps and the 4 KPIs of software delivery performance. More importantly, I'll show you how to put that theory into practice. That means shipping better software faster. Sign up today at freedevopscourse.com. Like the sound of Small Batches? This episode was produced by Podsworth Media. That's podsworth.com.